Section of chapter 3, we're kind of combining 3.7 and 3.8. So we're talking about slopes with parallel and perpendicular lines. So we're going to be using the equations of lines. So let's remember what. Oh, sorry, did I not turn it on? I guess you guys need to see it, right? If you hit blank, I think. No, I guess it turned off. So hit on. Yeah, there it goes. All right, there we go. Slopes of parallel and perpendicular lines. So let's start off by reviewing our equations for lines. So we have two main ways that we write the equations for lines. When our first one is called slope intercept. And slope intercept is the way that we usually think of lines. That is y equals mx plus b, where m is our slope, and b equals the y-intercept. And who can remind everyone, what do we mean when we say y-intercept? The y-axis, where it crosses the y-axis. So if I have just a quick sketch here, if I have a line like so, where it's crossing the y-axis is the y-intercept. And our slope is rise over run. We've talked about slope before. So the idea using slope shouldn't be something that's new. We've talked about the slope of lines before. So that's our slope-intercept form. M is a slope, B is our y-intercept. The form that's more useful, really, when we're talking about points on a graph, is called point-slope form. And when we write point slope, we say y minus y1 equals m times x minus x1. And our slope is m, and x1, y1 is a point on the line. So if I draw just a quick picture here, and I have a graph that looks like this, and we know that the graph goes through this point, that point would be x1, y1. That's our point in point slope. And the x and y are just our variables. X and y stay as x and y. So x1, y1 is our point on our line, and m is the slope. This is all stuff that we've seen, that we've used before. So I'm just kind of reviewing so that we remember it today. For the most part, we're going to be using point slope form, but I just wanted to remind you the two different forms that you see for the main forms you see for equations of lines. Yes. There are questions about parallel and perpendicular lines using slope on the test, yes. So what we want to do is we want to use these equations to talk about parallel and perpendicular lines. So let's talk about what we know when we have parallel and perpendicular lines. So questions about our equations for lines. The slope-intercept, y equals mx plus b. Point slope, y minus y1 equals mx minus x1. So when we have parallel lines, how are their slopes related? They have to be the same. Parallel lines have the same slope. Because if we graph them and they slanted at a different way, eventually they meet. So parallel lines have the same slope. So in our equations, if we have parallel lines, their slopes have to be exactly the same. Perpendicular lines. And by perpendicular, what do we mean? Cross at a specific angle. Perpendicular means 90 degrees. So perpendicular means they cross at 90 degrees. So perpendicular lines, we remember how their slopes are related. Anybody have a memory of that? Perpendicular lines have negative reciprocal slopes. And by negative reciprocal, it's written as a fraction. We flip it over and change the sign. So let me write a few examples of negative reciprocals. So if our slope is 1/4, the negative reciprocal would be, I flip the fraction, I would get negative 4, I could write it as 4/1. So the negative reciprocal of 1/4 is negative 4 or negative 4/1. The negative reciprocal of 3/2 is negative 2/3. The negative reciprocal of negative 5, I can think of this as negative 5/1 is 1/5. So we flip the fraction and change the sign. So all of these are negative reciprocals. So this is how we tell if lines are perpendicular if we have the equations for the lines. Their slopes have to be negative reciprocals. So let's take I just want to do a couple of examples of how we're going to use these. So let's say we have the problems that you might see with this are might ask you find the equation of the line through negative 2, 3 parallel to y equals 3/4 x plus 5. So we have a point here. This is our point. x1, y1. And our slope for our parallel line is going to be what in this example? It has to be 3/4 also. So this is our slope. It has the same slope as the line that we're interested in. So we have the point, we have the slope, so we're going to use our point-slope form to write the equation for our line. So this is x1, y1. We're going to write y minus 3 equals our slope, 3/4 minus x1, -2. And I can simplify this, y minus 3 equals 3/4 x plus 2. Minus a negative gives me a positive. And there's my answer. I'm not going to ask you to rearrange it or anything. If you write it like that, that's just fine. Yes?
So say if it would have been a perpendicular line, would it be -4/3?
-4/3. So if that's a good question. If we were looking for the perpendicular line, the only thing that we would do different is we would write this as negative, the slope would be -4/3, and that would give us a perpendicular line. So questions on that example? So we have a point, we have a slope. We write our equation, and this equation is just fine for our line. I'm not going to ask you to do any more with that equation. So let's look at another example. This time we'll talk about a perpendicular line. I'm going to add a little twist to our problem. So we want the equation the line through the point 3,7 perpendicular to (3x plus 4y equals 6). So this one's a little different. We don't know what the slope of this line is. How can we find the slope of that line? Anybody have an idea? Well, let's look back here at our slope-intercept form. What's by itself on this side of the equation? Y. So we can get y by itself, and then we could see the slope of our line. The slope is the number that's in front of the x. So I'm going to get y by itself. So I'm going to subtract 3x. I get 4y equals, and I'm going to write the minus 3x in front of the 6 because that's normally how we write it. Minus 3x plus 6. Now I'm going to divide everything by 4. I get y equals -3/4 x plus, and if I reduce this fraction, I get 3/2. Well, now we have our slope. Our slope for this line is -3/4. So what's the slope of the perpendicular line? What is it? Flip this fraction and change the sign. So there's my slope. Here's my point. So I can write my equation. Y minus, now if it helps out, and it's often helpful to write x1, y1, there's my point, and this is m. So y minus y1, y minus 7 equals the slope, 4/3 x minus x1, x minus 3. And there's my answer. y minus 7 equals 4/3 x minus 3. Slopes of these two lines are negative reciprocals. So those are the kinds of questions that I would ask you to do on the test. Find the equation of the line through a point that's either parallel or perpendicular to another. So questions on those two examples? All right, let's have a quick, just another quick review. If we have 2 points, x1, y1, and x2, y2, how do we find the slope between those points, Ashley?
The n equals x1 or x2 minus y, x minus y.
So think about, how do we think about slope? What do we call it without letters? What's our everyday way of thinking the slope? Rise over run. So rise tells us y has to be on top. Very good.
So y2 minus y1.
y2 minus y1, yes.
Over x2.
x2 minus x1. So that's, if we have 2 points, that's how we find the slope of the line between them. And if we have a graph, and we have 2 points on a graph, we could, if they're in nice places, we could count boxes, count spaces to get our rise and our run. Or we could just say that these 2 points are x1, y1, and x2, y2, and use our formula for the slope. So in your homework, there'll be some questions where they ask you to find the slope between 2 points, or they might give you 2 points like this and ask you to find the equation. So I can find the slope of the line using this formula, and either of these points can be x1, y1, or in my point slope form. So I could use either of these 2 points in point slope form once we have the slope. Yes. All right, so questions? Yes. Okay. So this is really all we needed to talk about today. Was just a reminder of our equations for lines, and talk about how slopes of parallel and perpendicular lines work. So we have 2 things. Let me stop this.